Now my new solar charger is finished, and I have in one side the connection to the solar panel, on the other side the connection to the battery, one switch for the internal battery or the external battery, and as all my projects, I always try to install something more, because we never know how or where we are going to use these devices, and that's why I've installed an internal battery, and just to place an LED. It's a 1 watt LED, nothing special, it's just the LED connected to the battery, no dual teeth to run this LED in or nothing. And I have I placed another switch for two options of light, one high, it's a very strong light, and one low. And as I said, we never know where we are going to need these devices, or where we are going to need light. And it is finished. I just need to place the cover. And that's it. The only maybe mistake I made is I've used this to tell me when the battery is charged, and the problem is that the voltage that comes from the solar panel is always higher than the voltage on the battery. And if I remove this diode in here, when the Schottky here, this is a Zener, when the Zener conducts, it begins using the energy from the battery. So I placed this diode in here to prevent that after the Zener conducts, it gets the power from the battery. And when I disconnect here the charger from the internal battery, then the Zener stops conducting and stops wasting energy. I think this was the only problem I have with this project. If I measure the voltage here, it's the voltage on the battery. But here is the voltage that is coming to the battery. So it is always higher. I'm reading on this area like 5.3 volts. So when I turn on the charge from the solar panel, this LED is always turned on, and this is the problem. If I remove this LED, this diode from here, then the Zener will read the voltage from the battery, but after it conducts, it will start discharging the battery. That's why I placed this diode. I still need to study more about how to use those Zener diodes to not to regulate the voltage, but a kind of stop charging mode, or at least how to know that the battery is charged using Zener diodes. Well, that's it. Now the project finished. It is working. It's working fine. I made just a little box. Now it's time for me to finish away to pack the solar panels. I need a way to fold the two solar panels and make the alligator clip connections. A little more work, but it's a lot of fun. This is it. Thank you for watching. Greetings. I'm making the first tests on a new solar charger I'm trying to create, and I'm using just fixed inductors, 100 and 1000 microhenry fixed inductors. And here is the testing board. I'm using MPSA as the driving transistor, and then boosting the, I don't know if it is right to say that because I don't have a scope, but I'm boosting it with 13005, then going back to the battery, and I'll place the schematics after testing. These are the first tests I'm making. I don't know how much voltage it's coming from the solar panels, but they are 5 volts, 500 milliamps, and they are inside a light chamber that I made for testing. This light chamber has two 15 watt CFL, and it's coming to cap, and then this cap is feeding the circuit. It's the same process of the other chargers. The charging battery is in series with the cap, and then I am feeding the driving transistor, the MPSA. From the collector I'm driving the MGA 13005, and from the collector of the MGA I'm going back to the positive of the battery. Uh, the battery is getting 0.07 milliamps, and the capacitor is with 1.93 volts. The difference I'm trying to measure right now is if I take the return to the battery from the MGA or from the MPSA 06. This LED that is on is coming from the MGA 06. I'll disconnect the MGA part of the circuit now and connect to the collector of the MPSA to see if I have some gain on the amperage that goes back to the battery. So I'm disconnecting the MGA from the collector of the MPSA, and now I will connect the ammeter to the collector of the MPSA here, and well, much better. Now I'm charging the battery with 3.5 milliamps. Yeah, much better. Well, I can remove the MGA part of the circuit and try to improve this pulse from the PSA 06. Well, the other transistor were removed. I think maybe simpler is the better, right? And the idea in here is the same as when I made my first solar chargers. I have a cap across the solar panel to accumulate the voltage that comes from the solar panel until it gets a higher voltage than the charging battery. And this other cap, the main idea is that as you increase the resistance from the base, this cap also gets a higher voltage. It's with 3.19 volts, and then as this cap gets a higher voltage, the pulses to the battery from the collector gets higher too. I found a sweet spot in here, and I was able to charge the battery with almost 3 milliamps. The battery is now charged. It's with 1.3 volts. It's just a 1.2 volt battery. It was discharged and now it's charged. My goal in here is my solar panels got lost in the customs, and I have only two panels of 5 volts each, and I need to charge my 12 volt batteries. Then my goal is how to charge a 12 volt battery with a 10 volt solar panel. I mean, to find a way to charge a battery that has as a source a lower voltage solar panel. Let's say to charge a 9 volt battery with a 5 volt solar panel, as I'm trying to do, is to charge 12 volt batteries with a 10 volt solar panel. The tests will continue. Now I'm going to change this battery for a lead crystal battery, and I placed a diode and a cap in here, because when I connect the positive of the battery with the collector, I'm afraid that only the LED will be not enough to block the voltage from the battery. So I placed this is a germanium diode and another 0.01 cap. This is the first attempt to charge a 12 volt battery using a 5 volt solar panel. The solar panels, the light on the the light chamber is off. The cap across the solar panel is with 2.55 volts, and the battery is with 9.45 volts. The cap on the circuit is with 2.5 volts, and I'll turn the light chamber on and see what will happen. Let me try to place the cap voltage on the same frame here. I think it's now all on the same frame, and okay, I'll turn the light chamber on, and the voltage on the light chamber on the cap is increasing. The voltage here is also increasing. I'm now going to connect the circuit on the negative of the charging battery, and let's see what will happen. The idea is that when the voltage across the solar panel reaches a voltage higher than the battery, I mean when the voltage across with the cap across the solar reaches a voltage above 9.7, then the circuit will start, and let's see what will happen. And I don't know if this will work, but the cap is filling up. It's now with 756, and I'll wait a little more until this cap fills it up, and if the circuit will turn on by itself. Well, after a lot of thinking, a lot of testing, I still cannot charge a 12 volt battery with a 10 volt solar panel. I will try again, but I think I did my best with this new solar charger. The solar panels are producing about 9 volts. Here on the exit I'm with 8 volts. The battery is with 4.25. The difference between the battery and the input from the solar panel is 3.78. That is the voltage which this circuit is running. Sorry. This circuit is running. I'm putting 4.7 milliamps into the battery, and this is the circuit. I tried to keep it the most simple as I could. I've tried a lot of Darlington kind transistors. I'm using here an MPSA06. I've tried the 2M2222, the 2N3904, the TIPs, and I've tried to use like a Darlington type with another MPSA, 2M and everything, but this is the best output I could get. 4.64 milliamps going to the battery that's now with 4.27. And that's it. I think this will be my new solar charger, and it's very similar to the ones I have. I'm trying to make it better, to maybe be able to charge my 12 volt batteries with the 10 volt solar panel. So that's it for now. I'll make a few more tests, try to record the improvements, and if not, I will finish this and box this charger to be the new solar charger. Okay, let's run the first test using the sun. Here I have the amperage, here the voltage on the battery. I now have to connect the circuit. Here is okay. here is connecting the amp meter. Okay, I have to connect the negative. Here is connected. I have to connect the positive of the circuit, connected, and now connect the positive of the solar panel, and let's see what happens in here. Well, I'm charging the battery with, let's say, let me change the scale here. $17 milliamps, and the solar panel is giving me about, it's in here. Let me try to place this in here. It's giving me around 11 volts, and I'm with 16 milliamps going to the battery. Let me try to change this potentiometer. Oops, more than 20. Very good. Now 25, 0. I can feed the battery with 23.678. 23.8 millivolts, milliamps into the battery. Very nice. Maybe with if the solar panel is giving me around 11 volts, maybe I can charge my 12-volt batteries. I have to test. Why not now? Yeah, let me try this. Okay, I think everything is now connected. Let me try to connect just the solar panel, and let's see what will happen. Solar panel is connected. The amp meter here, from here, and the positive is on the negative, the positive is on the positive. Maybe I am, no, not even a single charge. Why? The positive from the solar panel is coming in here. The positive after the diode coming to the positive. The negative is going to the positive of the circuit. And here is coming to the amp meter. that is coming to here. Yeah, not a single microamp going to the battery. Why? Maybe if I decrease the voltage. No. Nothing happens. Negative, positive, solar panel positive, and the positive coming to the positive, and the negative going to the circuit. Yeah, I cannot charge a 12-volt battery. That's too bad. Strange, because I'm getting almost 11 volts and the battery is with 9.1. Well, this should run. Let me try something. Yeah, it's really not the circuit. It's the lack of power from the solar panel. Well, the circuit's running, it's tested, and I'll now try to box it. I can't forget to place a meter. I don't have one. Okay, I'll think about it. Well, just for the record, I can get 390 milliamps with direct voltage connecting straight to the solar panel. But then it's just DC voltage. There is no pulses going to the battery. Just pure DC voltage. After testing, and more testing, I decided that it was enough of testings, and I made the board to box this new solar charger. And all I have to do is to connect the solar panel of one side and the battery in the other side. I need something very simple, very easy to use, and the voltage on the battery is 4.25 volts. All I need to do is to turn on my light chamber and hope that everything works fine. So let's see, this is the first run. Turning on. Yeah, the protecting LED is working, the charging LED is working, and the battery seems to be increasing its voltage. Well, I replaced the potentiometer by a resistor. I just found a sweet spot with the higher amperage, and then I placed the resistor instead of the pot. I need this to be very simple, very small. I will try to place in a small box. I have to find a very small box to place this and pack the 2 solar panels and this board in a compact package. I need to carry this on my backpack, and that's it. A new solar charger. The secret's the same as my other chargers, and I could not make it better. I've tried, but I could not make it better. There are some difference in components, like I've used a germanium diode here and a Schottky. Nothing special. That's it. Another step is to box this and finish everything. Well, the box is almost finished. I place the connectors to the solar panels, to the battery. Here I placed a switch because I want to install an LED inside and use a 3.7 volts battery. I'll just fix a battery, I don't know, somewhere maybe here, like this, to power the LED. And this is for me to use this box when I'm not using the charger. I can use the LED and maybe, I don't know, we never know when we need light, right? And here I will switch between the external battery and the internal battery to charge with the solar panels. Almost finished. It's working fine. The battery is charging. That's it, a little more and another project is finished. I was maybe I tried this button cell. It's a 3.6 volts button cell, but when using with this LED does not last long. This button cell was inside this solar flashlight from China. I bought a few of this just to use the solar panel. It's a very weak solar panel, a very weak battery, and 3 LEDs in parallel. So this is it. A little more and this is finished. Well, I'm testing a way to prevent the overcharging of the lithium ion, and this battery can be charged until 5 volts safely. I charged this until 5.2 volts when one day I forgot to turn off the charger, but I want to make sure of the charge, and here I have 3.9 volts Zener, red LED, green LED, and I'm placing a resistor in here. I don't know the value of this resistor. Maybe it's just around, let's say, 63. But the idea is to light the LED when the voltage on the battery gets around 5 volts, from 5 to 4.7 volts, and this is the idea. And here's the voltage. Let me try to like this. Here is the voltage that is going through the LED, and the voltage that is going to this little test. And the only problem is that this is a 3.4 volts Zener, and it turns on. It doesn't turn off. I mean, even if I decrease the value, the voltage here, I'm with almost 2 volts. There is almost 1 volt going through the LED. This is something I have to learn, how to cut off the voltage from the Zener after it conducts. This is something I'll never learn. When I go to 0, 1 volt, let me turn off the Zener. Okay, the Zener there is not conducting. I will increase the voltage. The Zener is not conducting, and 3 volts, the Zener is not conducting, 3.5 no, 4, is it on the right place? Yes. And 4 volts. Wow, something is wrong. What's wrong in here? I missed the hole from the LED. Yeah, I missed the hole from LED. Okay. There. So my question is how to cut the zener, because if I let the zener connected to the battery to warn to turn the green LED on when the battery reaches the voltage. I mean, if I'm charging this battery with a solar panel, and in the charging process I'm spending voltage through the zener, an LED and a resistor, I'm losing power that could go to the battery, or losing. There, it turned it on at 5 volts. 4 volts. 4.7 is what I need. Yeah, 4.9, 4.8, well, that's okay. But until it reaches this kind of voltage, there is the circuit is running, and I don't know how much this takes in amps, but there is 1.29 volts passing through the LED. Ooh, okay, need more tests. Okay, here it is. At 4.7 volts, the LED turns on. There is 1.8 volts going through the LED, and 380 microamps going through the circuit. I don't think this will be a problem. I just need to think how to connect this. Okay.